Good day, everyone. For today's discussion that I will discuss is all about configuration and projective geometry and some types of configuration. First, what is configuration? By definition of configuration, a set of endpoints and endline in a plane is called a configuration denoted by M sub c and N sub d if each of the endpoints is incident to the same number c out of n lines while each of the n lines pass through the same number of d out of m points. In other words, m represents the vertices and n represents the sides while c represents the lines that are in the sum n. M sub c represent each point in M where there are C numbers of line passed through where lines are from some N and, N sub D will have a same thought or reason in M sub C. Note that Cm is equals to Dm. This equation or this note is to compute the M sub C and N sub C the product. We use this kind of note that Cm is equals to Dn. Let's tackle some types of configuration. There are in projective geometry there are many types of configuration. There are plane configuration, Mobius contour configuration, Pappus configuration, Hayes configuration, the surge configuration, ray configuration, Scala-Flee double six configuration, Cremona-Richmond configuration, Granboom-Rigby configuration, and Gray configuration. But in this discussion, I will discuss only three types of configuration, and they are Hayes configuration, Mobius contour configuration, and ray configuration. The first is Hayes configuration. By definition, is a configuration of 9 points and 12 lines with 3 points per line and 4 lines through each point denoted as 9 sub 4 and 12 sub 3, where 9 represent M, 4 represent C, 12 represent N, and 3 represent D. As you can see, D. After getting the 9 points consisting 4 lines or 9 vertex consisting 4 edges and 12 lines consisting 3 points or 12 edges consisting 3 vertex. This Hayes configuration is called as a dual configuration, as you can see because of this different number in sides and lines. Now for the representation or illustration for his Hayes configuration is this. As you can see, there is a 9 points which each points consists 4 lines, and also there is a 12 lines which each line consists 3 points. Now let's see. This point has a 4 lines which is 1, 2, 3, and 4. Next line is 1, 2, 3, and 4. Okay. Next point is this 1, 2, 3, and 4. Okay. Then so on and so forth. You should follow that step, and also this 4, 4.4, 0.5, 0.6, 0.7, 0.8, 0.9 will have a consist of 4 lines. in this, which is 12 lines consisting of 3 points. Where are the lines is that? This is the first line, 1, which consisting 3 points, 1, 2, 3. Second line, 1, 2, 3. Third line, 1, 2, 3. Fourth line, 1, 2, 3. Fifth line, 1, 2, 3. Sixth line, 1, 2, 3. Seventh line, 1, 2, 3. Eighth line, 1, 2, 3. Ninth line is this. Ninth line is this. 1, 2, 3. 10th line is this. 1, 2, 3. 11th line is this. 1, 2, 1, 2, and 3. Then the last line is, and lastly is this. 1, 2, 3. It means that there are 9 points where each points must have a 4 lines, and there are 12 lines where each lines must contain 3 points. In graph theory, we consider this as a vertex, and this is edges, and this is edges, and this is the vertex. Where 9 represent M, 4 represent C, 12 represent N, and 3
The next configuration
D.
that I will discuss is Mobius-Cantor configuration. Mobius-Cantor configuration is a configuration consisting of 8 points and 8 lines, with 3 points on each line and 3 lines through each point. It will denoted as 8 sub 3, 8 sub 3, which is equals to 8 sub 3. This 8 sub 3 is called as a self-dual configuration. As you can see, because it consists 8 points and 8 lines, where each point is consist 3 lines and 8 lines, or each lines consists 3 points. And always remember that if the points and lines have the same value, you can write this as 8 sub 3. This is, like what I said earlier, is self-dual configuration. Then after that, I will show you or illustrate or represent the Mobius-Cantor configuration. And this is the illustration for Mobius-Cantor configuration is this. Since as you can see, there is a 8 points, which is this 1, 2, 3, 4, 5, 6, 7 each, where each points consists 3 lines. Let's see. This point 1 is 1, 2, 3. This point is 1, 2, 3. This point is 1, 2, and 3. 3. Next line is this, which is 1, this 1, this 2, then this 3. Next is this is 1, this is 2, and lastly this is 3. Next point is this 1, this 2, and this 3. Next point, this 1, 2, 3, and lastly the last point is 1, 2, and 3. As you can see, that is how I can present you the 8 points where each points will consist 3 lines. Next, 8 lines consist 3 points. As you can see, there is a lines that is consisting 3 points. First is this. This is the first line consisting 3 points. This is the second line consisting 3 points. This is the third line consisting of 3 points. This is fourth line consisting 3 points. Fifth line consisting 3 points. Sixth line consisting 3 points, 1, 2, 3. Seventh line consisting 3 points, 1, 2, 3. And last line is this circle, 1, 2, 3. As you can see, it is so easily to understand because this configuration is a self-dual configuration. It will easily understand because they have the same value of points and line. The last configuration that I will discuss is the ray configuration. By definition of ray configuration, it is a configuration of 12 points and 16 lines where each point of the configuration belongs to 4 lines and each line contains 3 points, denoted as 12 sub 4 and 16 sub 3. As always, remember, this is 12 points where each points will consist 4 lines, and this is 16 lines where each lines consist or must have a 3 points. And this configuration is called as dual configuration. Dual configuration. Okay. As what I do in example 1 and example 2, you should follow the step or how did I get the each point must have a 4 points and each line must have a 3 lines. So I will illustrate or represent the illustration for ray configuration. As you can see, there the illustration is maybe complicated or hard to get, or maybe it's so hard to get what will be the how we will get the points and lines, which some lines will consist points and some points will consist lines. But this is so very, like in first and second example, you should follow the step. First, since we have 12 points, we count the points in this illustration: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, where each point must consist 4 lines. Let's see. This point it have a 4 lines: 1, 2, 3, and 4. This 1, 2, 3, and 4. Third line, third point: 1, 2, 3, and 4. Next line, this is 1, 2, 3, 4. This line is 1, 2, 3, and lastly 4. This this line is 1, 2, 3, and 4. This line is 1, 2, 3, and 4. This line is 1, 2, 3, and 4. This line at this point is 1, 2, 3, and 4. This line is 1 at this point is 1, 2, 3, and 4. And lastly, this point is 1, 2, 3, and 4. 4, 4, 4. As you can see, we define or we this illustration is show that there is a 12 points where each points consists 4 lines. How about this 16 lines, and 16 lines where each line must consist 3 points? Let's see. First line 1 consisting 3 points, 2 consisting 3 points, 3 consisting 3 points, 4 consisting 3 points, 5 consisting 3 points, 6 consisting 3 points, 7 consisting 3 points, 8 consisting 3 points, 9 consisting 3 points, 10 consisting 3 points, 11 consisting 3 points, 12 consisting 3 points, 13 consisting 3 points, 14 consisting 3 points, 15 consisting 3 points, and lastly 16 consisting 3 points. That's what you call the ray configuration. This ray configuration must called as dual configuration. As always, remember the process or how you should know that this configuration or the first second example. Just always remember that if the condition of configuration, which is the m sub c and n sub d, so always remember that m will represent the points which each point may be contain 3 or any values which is maybe positive integers, and n lines which consist any values of points, right? So always remember the configuration or the m sub c and n sub d. So always remember that. As you can see, these 3 example of configuration is easily understand, but there are many configuration that are so very complicated, and maybe this reconfiguration is maybe medium to get, or there is more harder configuration to identify. As always remember that this three configuration, as you can see, this three configuration is some configuration only. There are many configuration that you always remember. So as you can see, if you have a graph theory, you will must be easily to understand this kind of configuration. Before I end up this video or this topic, this configuration must may be related to graph theory, in some ways because of vertices and lines. But like what I said earlier, these points these points is may called vertex in graph theory, and which each vertex going to some vertex, this is called edge, which is called in projective geometry as line. That's what I conclude, that this is maybe connected to graph theory, because like what I said, vertices and lines that may included in this topic. As of I hope that you understand some configuration that I discussed to you, and it will help you to understand the configuration topic in projective geometry. Thank you, keep safe, and God bless.